In today's lesson, we're going to look at our final few circle theorem facts. This one that you can see on screen is called our alternate segment theorem. It involves a tangent to the circle, the point where this tangent meets, and a triangle that is formed within our circle from this point. As with before, I can move the points of my triangle and I should notice something about the angles within it. What we should have spotted is that these two angles here are equal, and also these two angles here. What we can say is that the angle between a chord and a tangent equals the angle in the alternate segment. This is where the alternate segment theorem name comes from. Again, you'll see that this holds true even when I move the points. I think the easiest way to remember this is to think about the two angles outside of your triangle that are on the tangent being equal to the angles opposite to them inside the triangle. So let's have a look at an example of this. In our example, we're asked to find angle x. I know that this angle just here is opposite to this angle just here within our triangle. So therefore I know that x is going to equal 54 degrees. I can use my alternate segment theorem and the fact that the other opposite angle in my triangle is 73 to say that this angle here must also be 73 degrees. Lastly, if I'm asked to work out this angle just here, I can use the fact that angles in a triangle or the fact that angles on a straight line equal 180 degrees to work it out. So I'd first have to work out what 73 add 54 is. I know that 3 add 4 is 7 and 7 add 5 is 12. That gives me 127. I then want to take this answer away from 180 degrees. So I'm going to first start off by borrowing. I get 10 take away 7, which is 3. 7 take away 2, which is 5, and 1 take away 1, which is 0, meaning that this angle inside my triangle is 53 degrees. The next thing that we need to recognise is that a tangent to a circle always meets the radius at 90 degrees. Again, you might need to use this fact to help you work out some missing angles. Here's an example. The first thing that we can say is that the angle between my tangent and radius is going to be 90 degrees. I can then use the fact that angles in my triangle add up to 180 degrees to help me work out angle x. I'm going to have to start off by adding 52 and 90 together. 2 and 0 gives me 2, 5 and 9 gives me 14, meaning I'm given 142 degrees in total at the start, and then need to take this answer away from 180. I need to borrow. I get 10 take away 2, which is 8, 7 take away 4, which is 3, and 1 take away 1, which is 0. That means that my missing angle x is 38 degrees. Our final circle theorem fact extends the idea that tangents and the radius to these points always meet at 90 degrees. In this particular fact, we're given two lines that represent the radius and tangents coming out of these points. The two tangents meet at a separate point A outside of the circle. We know straight away that the two lines that represent the radius must be equal. As with before, I can move point A and hopefully we can spot something about the lines that we're given. What we should notice is that tangents to a point are always of equal length. Again, this remains true regardless of where I move this point to. Let's have a look at how we can use this to help us find some missing angles. In my first example, I know that I'm given an isosceles triangle. That's because this length and this length are both tangents to my circle, and therefore they're going to be equal. That therefore means that this angle and angle x must also be the same. Because angles in a triangle add up to 180, I can start off by doing 180 subtract the 44 degrees that I'm given. I'm going to first need to borrow. I get 10 take away 4, which is 6, 7 take away 4, which is 3, and 1 take away 0, which is 1. I know that this 136 degrees needs to be shared equally between the two angles that are left in my triangle. So I need to do 136 divided by 2, and I can use a bus stop to help me get that answer. 1 divided by 2 is 0 remainder 1, 13 divided by 2 is 6 remainder 1, and 16 divided by 2 is 8, meaning this angle 68, and also my missing angle x is 68 degrees as well. In my second example, I first need to recognise that my radius and tangents are going to meet at 90 degrees. The next thing that I'm going to work out is this angle here, and I can do that because angles in the quadrilateral always add up to 360 degrees. So I need to start off by adding 90, 90 and 48 together. That means that the angles that I'm given are 0, 0 and 8, which is 8, 9, 9 and 4, which is 22, so that's 228 degrees. I then want to take this from 360 degrees to work out that missing angle. So 360 take away 228. First thing I need to do is borrow. I get 10 take away 8, which is 2, 5 take away 2, which is 3, and 3 take away 2, which is 1. That means this angle is 132 degrees. I can use my arrow circle theorem fact to help me work out why. That is, that angles at the centre are always twice the angle at the circumference. That means that I need to halve 132. Again, if I need to, I can use my bus stop to help me do this. 1 divided by 2 is 0 remainder 1, 13 divided by 2 is 6 remainder 1, and 12 divided by 2 is 6. That means that my missing angle y is 66 degrees. From here, I now need to think about my missing angle z. Z is inside my arrow, which I know is a quadrilateral. That means that all the angles add up to 360 degrees. I can start off by working this angle inside my arrow out. That's by taking 132 from 360. First I need to borrow. I get 10 take away 2, which is 8, 5 take away 3, which is 2, and 3 take away 1, which is 2, meaning this angle is 228 degrees. I therefore know that the three angles that I'm given inside my quadrilateral are 228, 66, which is y, that's what we've just worked out, and the 40 degrees down the bottom just here. So I'm going to add all of them together. 8 and 6 with 0 gives me 14, 2, 6 and 4 with the 1 that I've carried over gives me 13, 2 and 1 carried over gives me 3. That means I'm given 334 degrees so far in total. I now need to take that away from 360. Firstly, I need to borrow. I get 10 take away 4, which is 6, 5 take away 3, which is 2, and 3 take away 3, which is 0. That means that my missing angle z is 26 degrees. Your task for today is to complete the two worksheets that I've put on Show My Homework for you. The first worksheet is on the alternate segment theorem. The second worksheet is a bit of revision of all of your circle theorem facts, particularly with a few tangent questions towards the end. Please pause the video and have a go at these questions. Once you're ready for the answers, you can unpause. Here are your answers. As always, please check your work really carefully. Once you're happy that you've done this, take a photo and submit it to Show My Homework so I can see how you've got on. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.